Okay, for example number 1, we're going to show that the volume of a sphere of a radius r is v, which is equal to 4/3 times pi r cubed. Now, if we place the sphere so that its center is at the origin here in figure 4, then the plane p subscript x intersects the sphere in a circle whose radius from the Pythagorean theorem is y is equal to the square root of r squared minus x squared. So here we have a sphere, and it's going from a lower limit of negative r to an upper limit of r. And what we've done is we created this cross-sectional that represents a circle. And then what we have created is a right triangle. So r represents our hypotenuse. We have our value for x and our y. Now, recall that the Pythagorean theorem states that we have x squared plus y squared equals r squared. So if we want to find out what y represents, we can solve and isolate y, which here you can see that y ends up equaling the square root of r squared minus x squared. And if you notice that this y represents the radius of this circle. So this represents the radius of the circle. So if we want to find the area of that circle, it's going to equal pi r squared. Well, the radius is represented by y. And then we solve for y. So therefore, we're going to substitute y to be the square root of r squared minus x squared squared, which becomes r squared minus x squared times pi. So therefore, a of x, meaning that this area of that particular circle, is equal to pi times the radius squared. Now, using the definition of volume, where the lower limit is negative r and the upper limit is r, then we have the following. We're going to have the volume is equal to negative r to r of the area of that cross-sectional times dx, which is equal to negative r to r, and we're going to now use that function pi times r squared minus x squared dx. And now, if you recall from our definitions in the past, if you're going from negative r to r, that means we're going to have two areas the same on the left and on the right. So what we can do is we can go ahead and begin with a lower limit of 0 to r, and then multiply it by a factor of 2. And then we can also factor out the constant pi. So now we're going from 0 to r squared minus x squared dx. And again, we know that the integrand is even. Now we just need to find the antiderivative of r squared and minus x squared. Once we find the antiderivative, we can then evaluate it according to the lower limit of 0 and upper limit of r. And we get 2 pi times r cubed minus r cubed over 3. And then simplifying that entire solution would give us the volume of the sphere, which would be 4/3 pi r